Good afternoon. So, as usual, this is midwife Rahel, a student midwife, and then this page is mainly for learning and then discussion. So, as we discussed the last time about fertilization, we said today we'll continue with implantation and embedding. So that's what we are going to be doing today. After fertilization, the formed zygote is supposed to implant and then embed itself into the walls of the endometrium. So that is what we are going to do today. So when we talk about implantation, what is implantation? So let's just picture a seed, maybe a mango seed or a tomato seed that we want to plant. So when you take that seed, what do? You dig the floor and then you put the seed inside. You dig the soil, you put the seed in, then you cover the seed that you've planted. So when you cover it, you see that there is a small heap of sand that is formed. And after some few weeks, what do you notice? You notice that the seed that you've planted is sprouting out of the soil or the sand. So that is how our planting happens. That's the same way for the uterus. That is how implantation happens. But before then, what actually happens after the fertilization has taken place in the ampulla? So after fertilization has taken place, the fused and then the fertilized egg begins to move towards the uterus. So when it was fertilized, it was just one cell. So as it continues to move, it begins to divide. So the cell divides into two same size daughter cells, and those cells are known as the blastome, blastome, blastome. So that is the same looking, the same size daughter cells. So after dividing into two, it continues to move towards the uterus in the fallopian tube. Then it continues dividing into 4 cells, into 8 cells, and then by the time it gets to the entrance of the uterus, it divides into 16 cells. That's from 2 to 4 to 8, then to 16 cells. And by the time it's 16, it's in the uterus. So all the 2, 4, and 8 divisions are done in the fallopian tube. So when it gets to the 16th cell, it is no more a blastome. It is called morula. So after dividing into 16, the division continues to 70 to 100 cells, and by that time it becomes a blastocyst. And in the blastocyst, we realize that because the cells are now many, it becomes compacted like a hard ball. It becomes compacted and becomes a hard ball. And then when it becomes like that, the cells get to gather themselves at one side, and then that one is known as the inner cell mass. When they gather like that, it's known as the inner cell mass. Then there is a fluid-filled cavity in the cell, which is known as the blastocoel, blastocoel, blastocoel. Then that cell, it has 3 parts, and then we've spoken about the fluid-filled part, which is the blastocoel, then the inner cell mass, and then it has an outer shell. The outer side of the cell is known as the trophoblast. The trophoblast. And what are the function of these 3 parts of the cell? So this outer part of the cell, the blastocyst, that is the trophoblast, its function or its fate is to become the fetal portion of the placenta. And then it has 2 layers. We have the syncytotrophoblast and then the cytotrophoblast. And then the syncytotrophoblast is the one that is going to release enzymes which will degrade, or let's say it will dissolve a little of the endometrial lining, allowing the blastocyst to embed itself or to implant itself into the endometrium. So, and then that trophoblast, which is the outer portion of the blastocyst, it is the one that releases HCG, the human chorionic gonadotropic hormone. So the trophoblast releases HCG. And then what is the function of this HCG? So the HCG is going to prevent the corpus luteum from dying. When the corpus luteum dies, that is when it comes as menstruation. That means there was no pregnancy, no implantation. So this HCG will prevent this corpus luteum from dying, which increases the progesterone of the body. So as the progesterone increases, the endometrial lining of the woman thickens to hold the cell and then to hold it into implantation. So because if there is no progesterone, if there is no corpus luteum, the corpus luteum is coming to shed off with the endometrial lining, the endometrium, during menstruation. So when this HCG prevents the corpus luteum from dying, that means there is high progesterone, and then the wall of the endometrium, that's the wall of the uterus, inner wall, it will become more thickened and favorable for the implantation. That's the function of the trophoblast. When we look at the inner cell mass, which is the embryoblast, it is the one forming the baby. Yes, because after becoming an embryo, it becomes a fetus, then we get a baby. So this embryoblast has two discs, discs, D-I-S-K-S, two discs. And then this disc, we have the epiblast and the hypoblast. Anything epi is up, hypo is down. So we have the epiblast and then the hypoblast. And then they all have their functions. The amnion is formed from the epiblast, whilst the yolk sac is formed from the hypoblast. So this yolk sac, it later proliferates into finger-like structures called the allantois, A-L-L-A-N-T-O-I-S. The yolk sac proliferates into finger-like structures called the allantois. The yolk sac proliferates into finger-like structures called the allantois. So what is the function of this allantois? The allantois function is to act as a primitive excretory organ. You know, normally the placenta is the one that takes care of all these things, but in the first and second week of fertilization, the first and second week, there is nothing like placenta. The placenta is not yet functioning. So these are the ones acting as primitive organs. So this will act as the primitive excretory organ. So when the placenta comes, it will pack its load and go. So when the placenta is formed, then this one will degenerate. The allantois will degenerate. Okay, so the yolk sac will degenerate into a germ cell. Okay, so these are all just there to work before the placenta comes in. That's the function of these things. Then the first few weeks of pregnancy, the amniotic fluid is mostly from the mother's placenta, plasma. Is from the maternal plasma. So by the 20th week of gestation, then most of it, or almost all the amniotic fluid, is from the baby's urine, the fetus urine. So then let's go back to the scenario I gave about planting seeds. So that is the blastocyst as the seed. So it gets into the endometrial lining, then it digs the endometrial lining and embeds itself. So when it embeds itself, then the endometrial lining covers it up, forming a small hip over there, and that hip is known as the fibrin plug. So that is how it is, just like how we plant our seeds. That's how it is. So that's when it digs to implant itself, the woman can get a little bleeding. So that's why some people confuse it for last menstrual period when they are calculating the expected date of delivery. Most people get it wrong because that little bleeding they felt it was menstruation. So that is, and some people even say they menstruate during their pregnancy. It never happens. A pregnant woman can never menstruate because the menstrual blood is the endometrial lining of the uterus. So if that endometrial lining is already taken by the progesterone and then a fetus is already implanted there's nothing shedding. The corpus luteum did not die, so there's no way you can menstruate during pregnancy. So it's probably an implantation failure, or maybe whilst the blastocyst was digging the endometrial wall to implant. So that is how it happens. So when you picture the planting in the soil, the same way it happens. So by the end of the 12th week, then the implanted cell, the implanted blastocyst, then it starts sprouting out. Then it has a finger-like structure called the chorionic villi. The chorionic villi. So these things will make it root well in the endometrium. And all these processes, like all these time spans, like from the first week, second week, third week, throughout to the full term of gestation, there are names for them. So the first 2 weeks of pregnancy, first 2 weeks of gestation is known as the pre-embryonic stage. Pre-embryonic stage. Then from the third week to the 8th week is known as the embryonic stage. 3rd to 8th week is embryonic stage. Then from the 9th week to full term, 9th week to term is known as the fetal stage. The fetal stage. So all the implantation and embedding and then the cell division happens in the pre-embryonic stage. That's the first 2 weeks of gestation. So from the 3rd week, that is when the embryo begins to form. So what happens from this 3rd week? How does the embryo get formed? So remember we spoke about inner cell mass, which is also known as the embryoblast, which forms the embryo. So this inner cell mass undergoes a process we call gastrulation. So in the gastrulation, gastrulation, so in this gastrulation, the inner cell mass divides into 3 layers. That's the embryoblast. It divides into 3 layers. So we have the ectoderm, which is formed from the epiblast. We have the ectoderm, the outer layer, which is formed from the epiblast. Then we have the endoderm, the innermost layer, which is formed from the hypoblast. Then there is a middle layer, the mesoderm, and that one is formed from the primitive stretch. So earlier we spoke about 2 layers, which is the hypoblast and the epiblast. But through this gastrulation, this 2-layer disc differentiates into 3 layers, which becomes the hypoblast, epiblast, and then the primitive stretch. So the epiblast, which is the upper one, will be given as the ectoderm, the outermost layer. Then the endoderm, which is from the hypoblast, is given as the innermost layer. Then the primitive stretch also differentiates into the mesoderm. And then all these 3 parts of the cell, all the mesoderm, the endoderm, and the ectoderm, they all are the ones that form the parts of the fetus. So the endoderm will form some parts of the fetus, the ectoderm will form some parts, the mesoderm will form some parts of the fetus. So they all have. So the endoderm, that is the innermost cell, will give us the inner layer of the lungs, the pancreas, the liver, the digestive system, and the urinary system. That is for the endoderm. Then we also have the mesodermal cells. The mesoderm, that is the one forming these parts of the fetus. That's the circulatory system, the liver, the skeletal system, and the muscular system. These are all formed from the mesoderm. Then the ectoderm, which is the outermost ones, will give the hair, the nails, the skin, and then the nervous system. So those are the functions of this. So you see, these layers are the one of the inner cell mass, which is the embryoblast, are the ones forming the baby now. That is why the first 12 weeks of the pregnancy is very important. But most people miss this stage because they don't even know they are pregnant. Because this is the time the parts of the fetus is forming. And it's very, very crucial. So this is how the implantation and embedding takes place. So please, in case you have anything to add up, or any suggestions, any questions, or anywhere that I've made a mistake, so kindly correct me. We are here to learn anyway. We can't know all. No one knows everything. So this is where we'll stop for today. That's implantation and embedding. So if you are picturing it, just picture it like a seed that you are planting in the sand. That's how it is. Nature is very beautiful. So please, the next time we are going to talk about placenta. So placenta is like the most important organ right now, because that's what is giving everything to the baby, the nutrients, the oxygen, everything. So we are going to talk about placenta, and it's going to be lit. So please like, follow, share, and then let's learn more. Thank you.